Money, molo kunjani, wagwan, huyamora, morning, bonjour, mambo, dumela, and all that. So, just in case I forget one of the greatest, please don't get mad at me, right? Okay, assalamu alaikum, morning, bonjour, comment ça va, and all this stuff. So, listen, excuse me. Just get a question right now from a lot of students. So, without wasting time, it's the morning. It's out in the morning right now. So, without wasting time, so let me get straight and do the question. And like I said, always, you can learn from me. You can learn a lot from me. Also, you can learn a mistake as well. Just feel free. Just leave the comments there. Like I said, I can always get back to you. Whenever I make props, maybe I might make something little or little mistake. You can tell me, by it never be intentional. Just that you know. Thank you so much for time. So let's get straight to the question without wasting time. So there's a question here. One of the students came to me early in the morning, say, "Hey, my homework is due today, please, man." So let's finish the question. Remember, we had a 26 question. So that's a question right there. Question 11. They say question 11. So they say two pipes are used to pump the cement. Okay, so this person here want to build a house or whatever. Cement mixture. So this pipes want to pump the cement mixture out of the truck. So this truck, those truck where they drive, they go and pump out the cement so that they can use cement to build a house. The pipes work at the same rate. So so these two pipe means in this truck there's two pipes. So in this pipe they work at the same rate. The speed, the other pipe, they work at the same rate. So when pipe A works alone, sometimes say, I'm not gonna use both pipe. I'm gonna use only one pipe. So when it work alone, it can empty the truck in 45 minutes. So it takes about 45 minutes if it's work alone. So of course, if they're gonna be two of them, they work together, time is gonna be less because when you work together, they always say, unity is a power. So if the unity of power means if they work together, it's gonna be less time. So they say that both pipes are used together. So now they say, so sometimes this pipe can be used together to aim the truck. Problem if they want to save the time. So they say if they work together, if the two of them they work together, the truck, so when both pipes are used together, they aim the truck in two-thirds of the time the pipe B used. But we don't have a time of pipe B. We only have a pipe A, which is 45 minutes. So let's say, so we're gonna have to assume pipe B time equal to X. Let's say X is the time of pipe B. So then together is gonna be 2/3 of pipe B to empty the truck. Okay. Now suppose the pipe B takes X hours. So the pipe B, if you empty the truck, it might take X hours to empty the truck when it works alone. So they say which of the following is the equation used to find the value of X. Okay. So you wanna get a so I hope everybody can see the equation. Let's go straight to the solution. To the solution. So that's easy, man. Go to the solution straight away. Okay, so I hope everybody saw the question, so I'll just start to solve. So it's okay. So I'm gonna do this. I'm gonna divide this. I'll say okay, so solution, question 11. So I'm gonna say this is pipe A. Pipe A and this pipe B, and here is when A and B means two pipe work together. A and B all together work together. I hope everybody can see. So that's when they work together. So now we don't know the time of pipe B, so we assume, and they even say here, right? Assume, suppose pipe B takes X hours. So this pipe B, we're gonna say X hours. But we know the time. We know the time of pipe A is 45 minutes. So we're gonna say 45 minutes. But this is minutes. So we're gonna have to change this in hours. See, so whenever we have a minutes, we want to change in hours. We always divide by 6 minutes. So we're gonna say if somebody say, 30 minutes. So how are you gonna change 30 minutes in hours? You're gonna say, okay, 30 minutes. We know 30 minutes is half an hour. Everybody know that. If you don't know that, my man. So 30 minutes means half an hour. But how is half an hour? How that comes about? We say 30 always. If you want to change minutes to hours, take that minutes divide by 60. So then you're gonna get a half. That's why we say 30 minutes is half an hour. See? So so if pipe A took 45 minutes to empty the truck, so we're gonna say, so now we're gonna say this pipe A alone, alone, and this pipe B alone. So we say pipe A alone Pipe B, it takes X hours. Pipe A takes 45 minutes. So since you want to change in hours, we're gonna have to divide by 60, which is gonna be in hours. So 45 divided by 6 is gonna be 3 over 4. 3 over 4. So this is hours pipe A you could use to end the track, and this is pipe B takes X hours. Excuse me. So now we say, so this must say hours. This is time they take. Time in hours. Time, but in hours. Time in hours. But they mention something here. When these two pipes work together, when these two pipes work together, when both pipes used together, they end the track in 2/3 of the time it takes for pipe B. When they work together, they take 2/3 of the time it takes for pipe B. Okay, so when A and B work together, the time that it's going to take is going to be 2/3 of the time of pipe B. But what is time of pipe B is X. So 2/3 of X. That's it. So now we have created a algebraic expression using the data they have given to us. So now we want to go to the options. So we want to go to the option. So they say in the option, they say which of the following equation is going to use to find the value of X. Let's go back there. Which of the following equation is going to be used to find the value of X? So if you look careful, we have to look at this expression here. Excuse me, let me do this, man. Let me do this. Yes. So we're going to say, we're going to have to compare. So our equation now is going to be 3 here, 3 over 4, X here, and you have X, and you have a 2 over 3 X. So this is the data we have if you want to solve the value of X. So now we want to look, which equations among these is going to satisfy this situation. A and B, when they work alone, when they work alone. Okay, work alone, work alone. So when they work alone, the same as A, equal to work together. So this equation, we're going to have to look here. Excuse me. Oh, we don't have X here. Hold on. It's just 3 over 4. Just 3 over 4. Just 3 over 4 plus X equal to 2 over 3. So I want to look which equation is there. Okay, the first one. No, it's not true because this is 1 over X and this is not 1 over X. So this is not true because this is not valid and this is not valid and this is not valid as well. Okay. Second one. X is true, but the problem here is 4 over 3, but this is 3 over 4. So if you check careful quickly, we see this is a solution here. X plus 3 over 4. So which you see, X plus 3 over 4. X plus 3 over 4 equal to 2 over 3, 2 over 3X. So answer is 4. I'll go for this one. If I had to go for, I'll take that one. Like I say, you can learn from me. Also, you can learn from mistake. Whenever you identify any mistake, please just leave a comment. Say, hey, I'm thinking something there. I think this should be done like this. So I'm saying that's just my own personal opinion. So option 4. So I'm going to say for this equation here, I'm going to go to option 4 because I have X, and then I have 3 over 4. 3 over 4 equal to 2X over 3, 2X over 3. So that's option 4. So question 11, option 4. Question 11, option 4. Question 11, option 4. Okay, so I go to question 12. Question 12, excuse me. Question 12. So we're given a question here. They say when they travel 3 kilometers. So when they want to travel from one city to another, let's say when they was traveling from New York City to probably, let's say, to New Jersey, or from Soweto. When they was traveling from Soweto to Johannesburg to Guguletu, Cape Town, South Africa. So she traveled, she traveled part of her journey of her way. So when she was part of her way at a distance X. So when she was traveling, she didn't go all the way from Soweto to let's say to Soweto to Arusha or any party. She didn't travel all the way. Let's say Soweto to Serengeti, Arusha is somewhere one of the city. So she didn't go all the way. So she traveled part of her journey X kilometer. So when you say X, means it could be maybe 10 or 20 or 100. So we represent by X because you don't know how far did she travel by bus. And then we should arrive at a certain distance X. And then she decided, let me use the train, man. I felt like I don't want to use bus anymore. So at the train station, and they just a time, and then to complete her journey, so she had to use what? Train now, by the train. The average speed of the bus was 4 kilometers per hour. So this bus was traveling very high speed compared to the train. And average train travel is 20 kilometers per hour, faster than the bus. So the bus was very fast. Probably she started to feel dizzy. And some people, they don't like when mode of transport is very quick. So the entire trip took 5.5 hours. Which of the following equation can be used? Okay, so this is similar to the previous question. So now we're gonna have to create a algebraic expression. So this is what I'm gonna do. Excuse me. I always like to draw this small table, man. So I'm gonna say, okay, let me draw my table. So first of all, let me do an illustration. So consider an illustration. So let's illustrate the whole equation. Illustration. So how are we going to illustrate? So they say when you travel 300 kilometer. Can you see that? 300 kilometer. Okay, so if you travel 300 kilometer, so let's say this is Soweto here, town A and B, 2 stations. So I'm gonna give the name. Let's say she's from Soweto to Guguleto. So she's from Soweto. Let's call this Soweto. So travel from Soweto to Guguleto here, Guguleto. This is one of the towns in South Africa, man. Soweto is one of the towns where Nelson Mandela and Winnie Mandela was born and raised. You know, that's his home. Nelson Mandela was born Eastern Cape, but Winnie Mandela, Soweto. So this is one of the cities. But Guguleto is one of the famous places in Cape Town. You see, Guguleto. So she traveled, let's say, from Soweto to Guguleto, just like how we say travel 300 kilometers. So the distance from here to there is 300 kilometers. So now she traveled, by the distance X by bus. So she traveled from Soweto, and then she traveled all the way from Soweto all the way to certain other town. Or let's just say end of the town, So let's say northwest. So when she arrived northwest, so how distance they say X kilometer. So she covered X kilometer. And then when she get northwest, she used the bus. She said, you know what? Nah, let me change and use the train. So she decided to use the train. So from here now, northwest to Guguleto, which is a Cape Town, if this distance is X and the whole distance is 300, so to get here, I'm gonna say this has to be 300 minus X. This distance that she has traveled. This X can be 10 or 20 or something. So if I travel 10 and the whole distance 300, means I have to say 300 minus 10. But I wouldn't know. They say they travel by X, so we call it X. So it's gonna be 300 here minus X. This is the distance that she's gonna have to travel from northwest or Bloemfontein, which is a city in one of the coldest cities in South Africa, or Lesotho, let's say Lesotho to Guguleto, Lesotho to Cape, to Google, Lesotho to Google, Lesotho to Maseru, Lesotho to Guguleto, Cape Town. So this is the distance she traveled. But we have other data here. They say, the speed that the bus was 4 kilometers per hour. So when she was traveling by bus, it was 4 kilometers per hour. By the train, 20 kilometers per hour. Okay. So by the bus, the speed of the bus, so 40 kilometers per hour. But train speed is 20 kilometers per hour. So now they want us to create the algebraic expression. But they say the entire journey, it took 5.5 hours. The entire journey, 5.5 hours. Okay. So entire journey, 5.5 hours. Let me push this stuff there so that I can pull every time. So I'm saying, so the entire journey is a stuff here which is abstract. So okay, 5.5 hours. So time, the whole time from here to here, the entire journey, entire time that it took is 5.5 hours. 5.5 hours. Okay. So let's draw a table and then create expression quick. Okay. So I'm gonna do this. Let me use the pen quick. So I'm gonna say, okay, so let's draw a table here. Okay. So let's draw a towns. So we got 2 towns, right? We got 2 towns. So Soweto and Johannesburg, right? So we're gonna say, okay, so this is Soweto, town A, and this is Guguleto, Cape Town, Guguleto. Okay, so this is Soweto and this is Guguleto. So what we're gonna say, okay, so here, let's say this is speed. Okay, I want to show you the little formula face you should know from now on. You see what I'm saying? The knots, let me write here this little formula. Speed equal to distance over time. Oh, some of the students, I always see them, they draw some of the little box. They say, okay, to remember, I'm going to say X, S, T, means SXT. See, speed equal to distance over time. Speed equal distance over time. See, so you can write this table, memorize X, ST, X, ST. Or if you think you can find any way to remember, that's all. Distance, velocity, or speed equal to distance over time. So now we come here, right? So in this table here, I'm going to start to say, okay, distance, I'll say this is going to be distance. Okay, the first one is distance. And the second one, I could put here speed. So this is speed. Man, I hope everybody can see. If you can see, please let me know. This is it. Distance, this is speed, and this is time here. Time. Let me do this, man. Oh man, it's not visible. Okay, so I'm gonna say this is distance. Distance, or x distance, and the second one, speed, and the last one is time. Okay, so I'm gonna divide my table like that. Okay, we go and get all the data now. Okay, so now we have some of the data here. The distance from Soweto, Johannesburg, Guguletu, and all of that. So, okay, and these gonna be total. That's gonna be what? Total. So now we go. From Soweto to Guguletu, total distance we have equal to 300 kilometers. But so the distance from Soweto to Northwest is x. X. And northwest to Guguletu 300 minus x. Northwest, so this, let's call this northwest. Northwest to Guguletu 300 minus x. Now we go. The speed from Soweto to northwest is 400. So speed is 400. And the speed from northwest to Guguletu is 20 kilometers per hour. Okay. Time, we don't have a time, but we have a total time, so which is 5.5. Or we could say this is 11 because 5 times 2, 10 plus 1, 11 over 2. Here we go. So we can get time also here. See what I'm saying? We can get time of each and every individual, because we know from a little formula that I just showed you now, we say if you want to get distance, or if you want to get time, for example here, because look, if you want to get distance, say if you want to get speed, equal distance over time. If you want to get time, equal to distance over speed. If you want to get distance, equal to speed times time. You see, that's why it's better to write like that. See, because what you do, excuse me, let me show it again, because it's very important here for speed, distance, and time. If you want to get distance, multiply these two, speed times time. If you want to get time, divide distance over speed. If you want to get speed, distance over time. So for this case, what do you want? We want to get time here. So if you want to get time, how are we going to get our time? We say, okay, so we come here. What is our time? Time meaning take distance over speed. We have a distance, x. So we say x. And then what is our speed? 40. Now we come here. We have also distance from northwest to Guguletu. I think here I should have say Soweto to northwest, and this is northwest to Guguletu. I think that will make more good sense. Like this is Soweto to northwest, and this is has to be northwest to Guguletu, because yeah, let's go. So now this is going to be 300 minus x over 20. So now you see we have got algebra expression. So that means if I take this, add to this equal to their total. So this and this equal to total. Just like previous questions. So okay. So if, what do they want? They say we have to create algebra expression. So to create algebra expression, excuse me, I don't know the total speed. I don't know. But if I had to add them, I could say okay speed. But I'm not going to use the. I can use this one. I mean, I have a total time. They give me total time. So I'm going to say okay, if I take the time, because this is our time now in terms of in algebraic, from Soweto to northwest is x over 40 plus time from northwest to Guguletu, which is 300 over 20, equal to the total time which they give us, which is 5.5, which is 5.5 meaning 5 over 2, because 11 over 2, because 5 times 2 10 plus 1 11, so 11 over 2. And these are algebra expression. So then what you do, you go to the option and you see which is the right option. So this question 12, if you look careful here in this option, we want to see which one is this. Okay, excuse me. So x over 40, 300 minus 2, 300 minus x, 300 minus x, over 20 over 10, 11 over 2, option 1. So it's option 1. Yeah, 300 minus x. Yes, it's true. Same thing. You see, they confuse here in the second option. They say x minus 300. No, 300 minus x over 20, 300 minus x over 20, x over 4 equals to 11 over 2. So I'll go for option 1. Question 12, option 1. Okay, now we go for question 13. Like I say, you can learn from me, you can learn from a mistake. Please let me know. These are the options, but I'll personally going to go. It's just my opinion, go for option 1. Let's go for question 13. Question 13, excuse me. Question 13. Okay, so let's just go to question 14. Excuse me, question number 14. So let's go to question number 14. Let's go to question 14, man. So it's on the computer quick, excuse me. Okay, so that's a question right there. They say question, excuse me. So they say which of the following are true? So 1, -1, 1, -1 is geometric sequence. The second one, 1/2, 1/3, 1/4 is neither geometric sequence or arithmetic progression. Okay, this is geometric progression sequence, and this is arithmetic progression or sequence. Okay, the third one is 1/2, -1/2, 3/2, 5/2 is arithmetic sequence. Okay, A, B, these are options here. So which of the following is geometric? Let's take the first one is geometric. So to test geometric always, excuse me, I hope everybody saw the question there. So that's the question right there. I hope everybody have seen the question, right? So I can just go straight and do the question, right? If you cannot see, please pause and you can check the question, or you can write down if you just wanna, just in case you wanna write down. So, excuse me. So let's go. Probably can just solve right away there. So if you know anything, if you want to know if something is geometric, what you do, take a next term divided by the previous. If it's geometric, it must be equal to this next term divided by this. It must be equal to this next term divided by this. So you have to divide next. Remember, do not divide face divide by the second. For example, if somebody give me 3, 9, 27, this is geometric. Why? Because if I take term 3, this is term 1, term 2, term 3. If I take this divided by the previous, going to give me 3, because 27 divided by 9 equals to 3, and also 9 divided by 3 equals to 3, and this is called common ratio for geometric sequence. It must be common for if you take next minus previous. Do never take 3 divided by 9, 9 divided by 27. Never. You take next divided by the previous, right? Remember that. Put in your mind, right? Make sure you put in your mind. Keep in your mind. So the first one we're gonna have to taste. Now we say, okay, so -1 divided by 1 is -1. 1 divided by -1 also is -1. -1 divided by 1 is -1. So this is geometric. So for the first one, yes, it's true. Because when you take term 2, which is -1, divided by 1 equal to -1. Okay, let's go term 3. Mean this is the first term, second term, third term. Term 3 is 1. Divided by -1, we're gonna get also 1, which is common ratio. It's common everywhere. Let me do here. Maybe some other people they might not see. So say -1 divided by 1 equal to. So say -1 divided by 1. It must be equal to. Let's take this one. It's gonna be 1 divided by -1. Is it gonna be equal true for the last one? -1 divided. Yeah, it's true, which is -1. So for that case, this is geometric. So that's how you test geometric. So it's true for the first one. Now we go for the second one. They say the second one is neither geometric or arithmetic. Excuse me. Okay, so let's test. What is arithmetic? How do we test for arithmetic? You test for arithmetic. So this is what test for geometric. This is for geometric. So how do you test for arithmetic? You test for arithmetic. I'm gonna write here. I hope everybody can see. How do you test for arithmetic? Test. If somebody can, excuse me, let's say 2, 3, 5, 7. Arithmetic, you always take next term minus. Don't divide, minus. So you're gonna say, for example, you take. Make sure you must take next minus by the previous. So say, hey, you say I can't even take first minus second. No, I didn't say that. I say take next minus the previous. Always next minus previous. So how are we gonna know here? This is arithmetic. Now we go. This minus this equal to 2. This minus this equal to 2. This minus this equal to 2. Yes. So this is arithmetic because it has a common difference. It has a common difference. Common difference. D. Common difference. D. So they say for the second one, we're gonna have to test. They say it's neither geometric or arithmetic progression. So let's see first. Let's test for geometric. Geometric, we know we take next term divided by the previous. So a half divided by 1 is a half. If we take next term divided by previous, it's not going to be a half anymore, because if you take 1/3 divided by 1/2, let's see here, 1/3 divided by 1/2, and we know mathematical, if it's 1/3, we can flip it. If it's divided, say 2/1, so it's going to be equal to 2/3. So you see, it's not the same as a half divided by 1. So for that case, this is not geometric. It's proven already. Because you see, if you divide this one, you get the half. If you divide by this one, you get what? 2/3. So it's not geometric. Geometric, yes, we agree, it's not. So it's neither geometric. Let's see if it's not arithmetic. So since only this part here is not true, then everything is not true. Because they say which of the following is true. So only one, it just tells me everything is not true. But let me just test for arithmetic also. But it's already not true because one of them is not true. You know, from logics, if one is true, one is not true, then everything is not true. See, from logic, you know, there's something you're gonna learn from logic. Okay, so for arithmetic, we can say we take next term minus previous. So say half minus 1 is gonna be negative a half. Now we wanna see 1/3 minus 1/3 minus 1/2. So 1/3 minus 1/2. 1/3 1/3, excuse me, minus 1/2 minus 1/2 is negative 1/6. Negative 1/6. So you see, these are not equal. So it doesn't have a common difference. So it's not even arithmetic as well. Even if it was going to be arithmetic by minus, then it's not answer because one of them is not true. But they're both not true. So still not true. Okay, so now we go for the next one. They say this is arithmetic. So we take next minus previous. This minus, if you want to see if it's going to give us the same common difference. Excuse me. So the first one is true, but the second one is not true. Now we go for C. So for C, so now let's minus. So I have a calculator here. So we're going to say, okay, so take negative half minus a half is going to be negative 1. It's going to be positive 1. Let's prove. Okay, fraction. We go negative a half, negative 1/2. Then we minus a half, 1/2. What we got? We got negative 1. You see there? Negative 1. So for the first one, this minus this, you get negative 1. Let's see there. No, my apologies, man. This one here. Negative 1. Now we go for this one. Negative 3/2. Negative 3/2. Minus. Remember that, man. Negative 1 also. This also gives us negative 1. Now we go for the next one. And when you minus, look, they sound the students sometimes they make some silly mistake here. Excuse me. They say negative 3/2. So you should do negative 3/2 minus over 2. So it's minus, but it must be minus, but our previous term is minus a half. You see, minus, but our previous term is minus a half. Minus 1/2. So minus plus 1/2, and they have negative 3/2. So final is going to be equal to negative 1. See, so make sure you pay attention. Next term is a term made this term minus it must be there in the middle always, like what I did minus, but the previous term is negative 1 is minus, and previous term is negative a half. So we find also negative 1. When you go for the next term, also should be the same, I believe so. Okay, let's go. Negative 3/2. 3/2. Okay. This negative 5/2. Yeah, it's true, negative 1. So this term is arithmetic, it's true. So it's only A and C. So this is true here. So only A and C. So option 4. Question 14, option 4. Question 14, option 4. 14, option 4. Question 14, option 4. So let's go to question 15. Okay, see, question 14, option 4, yeah, A and C. A and C. Okay, now we go for question 15. Question 15. So now we go to question 15. Okay, question 15, they say which of the following are true. So which of the following are true? So let's break this one, man. They say 10 term of geometric, If the nth term of geometric then is 1/, the common ratio is, if the arithmetic with a common difference, like how we see. I hope everybody can see the question. If you cannot see, please pause and read the question. So let me slide up. Everybody can see, you can read. Also, you can pause the question, right? So I'm going to start for the first part here, right? They say, which of the following is true? The 10th term of geometric means this is first term, second term, third term, and this is 10th term. Okay, so let's go to the solution. So solution, excuse me, question 15 solution. Let's start C A phase. They say the A, they say 10th term of geometry is, so they give us a lot of term here. So let me write those terms first. So they give me first term, which is 0.1 and 0.01 at the second term, and 0.001 third term, and they say the same 10 term is going to be 0.1 or times 10. So first of all, I need to know the form of getting number of terms for geometric. So to get number of terms for geometric, you always say Tn equal to A, which is the first term. They say common ratio n minus 1. That's the formula you use. So now we're going to have to plug it in what we have. They say 10 term. What did I say here? The 10 term. 10 term. See that 10 term? Let me use a red pen here. I don't want to say, oh, I didn't see the 10 term. So 10 term means our number is 10. So we're going to say term number 10, because there's a formula here we use for any term in geometric. How do you use geometric? Because they say here geometric sequence. So, excuse me, the 10th term equal to A the first term, but we have a first term given in that given party. There's 0.1, and then always I will encourage you to put bracket. Not necessarily, but it's always good to put bracket, because you treat these the one number or one term. Exponential is the one term. So we say other. How are you going to get other? Other is the common ratio. Say whenever you have a geometric, you take next term minus previous to get the common ratio. Next term minus previous to get the common ratio. So how are we going to get common ratio for this case? So we're going to say 0.01 divided by 0.1 or 0.001 divided by 0.001. Okay, so let's divide this out of here. So common ratio equal to 0.01 means this divided by 0.01, no, 0.001 divided by, or it could be 0.01 over 0.1. So you divide there, 0.01 divide by 0.1. 0.01 divided by 0.1. Okay, let's see. Okay, so now we get 0.1. So this common ratio is going to be equal to 0.1. So here I'm not going to say I will say 0.1, but I have n. What is my n? Let's say 10m. So it's going to be 10 minus, what is n? Just n, because n is 10. So my 10. Okay, so for that case I'll say 0.1, and this is going to be 0.1. 10 minus 1 equal to 9. Okay, so this is what I have. So mathematical, excuse me, see this term here are same. We know from exponential rule, if I have a x times a y, you see when the base are equal, see the base are equal, these are power, these are power, the base are equal, and there's a multiplication, you add the power. So you see a and they add the power only when the base are equal, but when they're not equal, please never do that. Only when they're equal. So if somebody give me, let's say 0.5, 2 times 0.5, 1. So what I'm going to say, I'll say, because the base are the same, so I'll say 0.5 and then add the power. 2 plus 1 equal to 3. So same here, 0.1 is 0.1. This power 9. Since there's no power here, so I'm going to put power what? Power 1. Because anything when there's no power means power 1. For example, 1000 means it's power 1. 2, even if there's no power means power 1, because 2 power 1 equal to 1. Plug in the calculator, you see. So now, since the base are the same, so I'm going to write only 1, and then I'll add the power. So it's going to be 1 plus 9, which equal to 10. So finally 0.1 or 10. This is 10. So I think this is correct here, according to how they say. Yeah, it's true. So they say the terms of geometric sequence, the 10th term is 0.1. 10 is true. Yeah, it's true. So that's true. Now we go for B. So for B, so A is true. So we go for B. If the nth term of geometric sequence is this one, and the term, I think I copied this question wrong here. Let me check again. Okay. Apology. Okay. I think I copied this question wrong here, man. If the nth term of geometric sequence is this one, and the term is, which term here? I think I copied wrong. My code. I'm gonna have to recheck this question. So jump for the table, right? I think I've recopied it. I just copied this question. I think there's something missing here. I apologize. Okay. There's a common ratio good negative. Okay, so I'll jump to C, and then while I'm checking this stuff here on my other computer, in the other paper, and see where did I copy wrong. I apologize. Okay. So I'll go straight to the C because I think I missed one of the 10 there. So for the C, Okay, so for the C, you say if the arithmetic sequence with a common difference D and geometric sequence with a common ratio R both have the first term of 1, then the 10th term can only equal. Okay, cool. Arithmetic sequence with a common difference D. So now you see they mix two things here, arithmetic sequence and geometric sequence. I'll go to the C and then I'll come back to B, like I say, because I think it's something that I covered here. Okay, so excuse me, question 15, okay. If the arithmetic sequence with a common difference D, so let's say here, arithmetic sequence. So this is arithmetic. Please, if you can see, please let me know. Arithmetic. And this is geometric. Geometric. Okay. On here, I'll get better soon that question. I think I should just check quick. Okay. So arithmetic and geometric. So they say if arithmetic sequence with a common difference D, so it has a common difference D, and A geometric sequence with the common ratio R, so we know always geometric sequence must have a common ratio R. They both have the first term of 1. Okay, so this one, first term equal to 1, and even here first term equal to 1. Then the 10th term can only be equal. They say the 10th term can only be equal. Okay, the 10th term can only be equal if R equal to okay. Okay, excuse me, sorry, I'm gonna check that question right there. Just a minute. Okay, I just get the part that was missing in the equation, so we go back and finish the equation, right? So let's just go, and if you have a question, just ask me. Don't never hesitate. Don't afraid of me. Ask me anytime. You can wake me up 2 a.m., 3 p.m., anytime. You know, I'm just here for you, man. Without you, you know, can't do all this, you know. So let's go to the business. Excuse me. So now let's finish this question. So to say, excuse me, I'll just go and read it quick. Okay, so we'll see, and then we'll go back to B. So arithmetic sequence with a common difference D. So we say arithmetic sequence with a common difference D and a geometric sequence with a common ratio R. Geometric sequence with a common ratio R have the first term of 1. So both have a first term of 1. Then the 10th term can be equal. So now we don't know. So what I'm going to do, let me find the 10th term of this and 10th term of this. So I'm going to say for arithmetic it's going to be Tn equal to, arithmetic equal to A plus N minus 1 times D, and here Tn equal to A Rn minus 1 for geometric. 10th term, so means here is going to be 10 here. So you're going to say 10 equal to A is just, they say 1, 1. So it's going to be 1 for both. And is 10. So this is going to be 10 here. N is 10 minus 1 equal to 9 times D. So 9D. And for this case of a geometric, geometric is going to be 10 equal to A is 1. They say A is going to be 1. Common ratio, I don't know. So 10. So 10 minus 1 equal to 9. Okay, so finally 10 of geometric equal to 1 times anything, just that anything, other times 9. And here 10 of arithmetic equal to 1 plus 9D. Okay, so we have a 10 for arithmetic and geometric. But they mention something here in the question. They say these can be only equal if the common ratio equal to this term here. Common ratio equal to this term. So of course we see they're not equal for now. This is 1 plus 9D and this is R power 9. You see they're not equal. But they say if we plug in R equal to 9D plus 1 exponential 9, then these two terms for arithmetic and geometric, they're going to be equal. What that means? If this R here, see this R here? If I replace with this term and then these 10 terms, they're going to be equal. So what that means, let's replace now. So we're going to replace this R, because they say when R because now we see these 10 terms are not equal, and according they say their 10 terms can only be equal if this other here, if you put other, okay, so now we're going to place this other with square root of 90 plus 1. See this other, but that is power 9. But remember, outside here means we have replaced this other with this, which is this one given. But we have a power 9, so power 9 here. So what happened? This and this gonna cancel. So we're gonna be left with 90 plus 1. Excuse me. This and this gonna cancel. Yeah. It's just like if somebody gave you square root of x power 3 and then you square root 3, means this and this gonna cancel. So means square root is gonna go away. So this and this 9 is gonna go away. So 9 plus d. Or sometime other people that could have said, okay, let me plug it again another way. So other, what is other? But I think it's obvious, everybody can see. If you have a problem, please let me know. Our other, what is the other? We say other is square root of d. Look, I'll do it again, just do it again. Square root of d, and that's my other, but a power 9. So what happened? Means this root has a 9 and this has a 9, it goes away. So now we're left with 90 plus 1. So we see all they are equal. So when this other, excuse me, this other equal to, like how we see the 10 term are equal, because look, 10 term of arithmetic now equal to 1 plus 90, and same as 10 term of geometric also is 90, and 90 plus 1, or 1 plus 90. So it's true. So the third one is true. So this is true. So I want to check for the second term. I said for the second term, I had a feeling that the might be mistake, and it's true. I've checked it now. It's true. There was a mistake. That's why it was not make sense. So the question should be, if the 10th term of geometric sequence is this, then the first term here is supposed to be first. Sorry about that, I didn't copy wrong. So So we want to check. So let's go. Excuse me. Let me take a paper here quick. Okay. So let's do the second one now. So we see A and C is true. So now the middle one. So they say if the n term of geometric, but what is n term of geometric? Excuse me. They say the n term of geometric means Tn is given by 1, 3, n minus 1. This is the n term. Tn. It just n term means this term can work in any terms of geometry, which is given equal to 1. You can see the 1, negative 3, this one right here. Okay. And the first term equal to is, and the first term is negative 1. So but they say our first term equal to negative 1. Our first term equal to negative 1. Then they say, then the common ratio is 3, 1 minus. Okay, so they say if n term of the geometric is this one, and the first term equal to that one, then the common ratio is this one. Okay, so if this is first term, they say then if that's the case, then our common ratio is going to be 3, 1 minus n. So we can prove this. Excuse me. So first of all, I know Tn of any geometric is always a ara n minus 1. N minus 1. But where they have given us Tn. So now I'm not going to write this Tn. I'm going to write this given here, which is what? 1, negative 3, n minus 1 equal a. A equal to negative 1. So we're not going to write a because we substitute everything in the formula. They give us Tn. Tn is substitute here. Equal to a. A given equal to negative 1. Negative 1. Common ratio. So now they ask, if that is, will our common ratio be equal to this term? So we want to prove now, right? So, excuse me. So we say our common ratio is error n minus 1. Excuse me. Okay. Or in other way, excuse me. Or in other way, I could have said but no, I don't think that's a great way of doing it. I could have said, let me do like this. My apologies. Let me. So we want to find what ara. I could even do like this. We want to find what this ara now. So we want to get ara to see if this ara is going to be like this. Also, I'm going to show you other methodology also. Excuse me. So now, so we're going to divide everything by negative 1, means divide this out by negative 1, divide this by negative 1, negative 1 is going to be positive, so it's going to be 1 over 3, so this is going to be positive, n minus 1 equal to ara n minus 1, but I can break this, so this time I say ara n times ara negative 1 equal to 1 over 3 n minus 1. Let me make a space here because I'm going to do other methodology also, excuse me, other method also. Okay, so I want to get what? Ada only, excuse me. This is correct, but I could. What I want to get? I want to get common ratio, right? I want to see if the common ratio is that one. Okay, let me do other method. This is correct, but it's going to take me longer. Apology. Let me do shorter method. So they say if a equal to -1 and this is n and this is common ratio going to be this one. So what I'm going to do? Let me write my formula and plug this to see if it's true going to give me Tn. If it's true, that's going to give me Tn. So I'm going to say I'm going to plug the formula again. So like I said, I could have done that, but I see that that's a longer method. Say Tn equal to a out of n minus 1. So they say a equal to -1. I'm going to say, okay, a equal to -1. Ada. So they say is ada going to be this. So if I take this ada plug in here, if it's, then we have to see if it's true, we're going to give it this one. If it's true, it's going to give it this 10 here. So I'm saying, so I'm going to plug in this ada here and see if truly going to give us Tn 1 -3n minus 1. If it's true, then yes. If it's not true, then it's not true. It's not true. So it's okay. So what are ada? Our ada 3 1 minus n. So let's simplify and see if it truly that one Tn. Okay, so -1 3 1 minus n. But we can reciprocate mathematical not before I do that one, right? If somebody give you let's say x power y, this one you could have say 1 over x and then this is positive, it become negative. That's what we call reciprocal rule. That's how you reciprocate exponential. So if somebody give me, let's say p 1 minus y, what does that mean? I can reciprocate this. So when you reciprocate, it's going to be 1 over and then everything is going to come underneath. It's going to be p, but the sign of everything is going to change. If this is positive, it's going to become negative, and this negative is going to become positive. See, that's how you reciprocate. So I'll do the same thing for this one here. Because it's correct, this is Tn, but I want to see if it's going to give us this term here. And you can see this term is already reciprocated. So we're going to say, okay, so we have our Tn, is how we see there, -1, 3, 1 minus n, and then let's reciprocate. It's going to be -1, and then when you reciprocate, it's going to be 1 over reciprocating, so this is going to be 3, this is going to become -1, and this negative is going to become positive. So negative times, so it's going to be negative, and then, excuse me, so this time is a 1, and then 3. My grade 1 teacher, I remember she told me my grade 1, 3, 4 is always good to start with a positive. So I'm going to say positive -1. And then finally, negative times anything, just negative. So negative 1 over 3 n minus 1. So we want to see if this is Tn is true. Yeah, it is true. So A, B, and C are true. So yes, it's true. So this is true also. So A, B, and C are true. So we go to the options. Man, no, we don't have option A, B, and C are true. So we do something wrong here. There's something wrong here. There's something wrong here. Which one is wrong? We don't have A, B, and C. Is only A true, B true, C true, only A and B, or A and C? So of course A is true, just by the logic. A is true. So between B and C, one of them is not true. One of them is not true. Okay. I think let me recheck this one. Okay. Trust me. So let's check it again. Yeah, I think I just saw where I did a mistake. So you know, something little, man. I also say when you see my mistake, please tell me right away. You can write a comment. Of course, I might make not intention, you know, but I can always rectify. So let's go back again. Excuse me. So I see where I made a little mistake. Out of there. So let's go to the other. So let's go there. I see a mistake. So I'm gonna have to redo the question. Quick. So let me show you why I make mistake. Quick. Why here is why I make mistake? Because say R power n minus 1. So I forgot to say n minus 1 right there. That's a mistake I did. And that's why everything was. So C of course not true. See? So probably I can do here. Yeah, let me do here on the same page so that you can see where I made mistake. So our A equal to -1, so C is not true. And other equal to 3, 1 minus n. Okay, so we want to see if this A equal to this and this other equal to this. Let's see if true Tn equal to that one, right? So I've seen my mistake, man. Okay, so we say Tn, we want to see if Tn is going to give us this. So what is the A? Let's write formula first. A, other for geometric, minus 1. What is the A? A equal to -1. What is the other? 3, 1 minus n, and we still, this is only other, and then we still have a n minus 1. That's a mistake I did. I forgot to multiply n minus 1 because there's an n minus 1. So now for that case, now we say equal to -1. So we can multiply these two. So this is going to be 3. Okay, 1 times n is n. 1 times -1 is -1. 1 times n is n. 1 times -1 is, okay, let me multiply sides, so it's okay. 1 minus n times n minus 1. Let me use the right pen here. Okay, so let's multiply. So we say 1 times n is n. 1 times 1 is -1. -n squared, and that's going to be -n times -1 equal to positive n. We can rearrange. Okay, this and this, they give us 2, so we're going to say -n squared plus 2n minus 1. Okay, so this is going to be -n squared plus what? 2n minus 1. Okay, so now we say if we have to reciprocate, you say equal. Only if you have to reciprocate, it's going to be -1 over, I'll take everything underneath, which is going to be 3n squared minus, because when you reciprocate everything, it's going to change, positive, negative, negative, positive. So this negative is going to become positive, and this positive is going to become negative 2n, and this negative is going to become positive plus 1. So it's not true. So these are Tn. These are our actual Tn. So this is not equal to what is given here, which is 1 negative. So when this is Tn and this is first term, common ratio should never be this one, because you have tested if you take the common ratio in first term, it does not give us this one. It gives us this term right here. So B is not true. So A and C. So B is not true. So this is not true. I almost make mistake. That is why I don't like multiple choice. So A and C. A and C. So question A and C. So question 15, A and C. Option 5, A and C. Option 5. A and C. So now we go to question 6. Question 16. Question 16.